For decades, we thought we knew what was out there. We pointed our telescopes into the abyss, built our models, ran our equations, and we were certain. Pluto was dead. A frozen, barren rock drifting alone at the edge of everything. Small. Insignificant. Forgotten. NASA said so. Textbooks said so. The entire scientific world agreed. They were wrong. And what New Horizons found when it finally arrived, after traveling 3 billion miles through the blackest silence in our solar system, didn't just surprise scientists. It shattered what we thought we understood about how worlds are born, how they die, and what the universe is actually capable of building in the dark. Imagine launching a spacecraft in 2006 and waiting 9.5 years. Nearly a decade of silence, of trust, of sending something you built with human hands into a void so vast it defies comprehension. New Horizons traveled at over 36,000 miles per hour, faster than any spacecraft ever launched, and it still took 9 years to reach Pluto. That distance alone should terrify you. In that time, children became teenagers. Teenagers became adults. And all the while, a small piano-sized probe drifted further into deep space, sending back nothing but silence. Then, in July 2015, the first images arrived. And the room full of NASA scientists and astrophysicists, people who had dedicated their careers to space documentary-level discoveries, went completely silent. Not because Pluto was what they expected. Because it was something else entirely. The models said Pluto should be geologically dead. No internal heat. No activity. Just a cratered, ancient, frozen wasteland. What New Horizons photographed was a world alive. Mountains of water ice, rising over 11,000 feet, younger than the dinosaurs on Earth. A vast, nitrogen ice plain called Tombaugh Regio, a heart-shaped region so smooth it suggests active geological processes happening right now. On a world with no business being alive. This violated fundamental assumptions in planetary science and astrophysics. If Pluto, this tiny, distant, frozen world, can sustain geological activity without significant solar energy, then our entire framework for understanding where life, where complexity, can exist in the universe, needs to be rewritten. Because the universe doesn't follow our rules. It never did. But here's where it gets stranger. Here's where the astronomy facts stop feeling comfortable. The question that kept scientists awake wasn't just what Pluto had. It was why. One leading theory involves tidal heating, the same gravitational phenomenon that keeps Jupiter's moon Io volcanically active. Gravity, when applied across a body, creates friction at the molecular level. It squeezes a world from the inside. It generates heat from pure physics. Einstein's theory of general relativity tells us that mass warps the fabric of spacetime itself. We think of gravity as a force, a pull. But it isn't. It's a curve in reality. And when massive objects interact across that curve, energy transfers in ways that can warm the interior of a world billions of miles from its star. This is the same physics that governs black holes. The same gravitational time dilation that causes time to slow near a supermassive black hole also, at vastly smaller scales, could be responsible for keeping Pluto geologically warm. The universe uses the same rules everywhere. From a singularity at the center of a galaxy to a frozen dwarf planet at the edge of our solar system, the physics is the same. Gravity doesn't care about scale. And that is terrifying. And magnificent. Imagine standing on Pluto. The sun, our sun, is so distant it looks like nothing more than the brightest star in the sky. Not warm. Not comforting. Just a sharp point of cold light in an ink-black sky. The temperature is negative 375 degrees Fahrenheit. Your blood would freeze before your mind could register it. But look up. Look up. Pluto has a sky. A thin atmospheric haze, layers of blue, refracted by nitrogen and methane, drifts above the surface. It's hauntingly beautiful. A ghost of an atmosphere on a world that shouldn't have one. And the mountains. Standing at the edge of Tombaugh Regio, you'd see ice mountains stretching toward that black sky, carved by forces we're still struggling to explain. The ground beneath you, smoother than almost anything on Earth, suggests this plane has been resurfaced. Geologically, recently, something is happening beneath the surface of Pluto. Something that, by all our models, shouldn't be happening at all. But here's the question that no space documentary wants to sit with for too long. If we were this wrong about Pluto, a world in our own solar system, around our own star, what else are we wrong about? We've spent decades mapping the event horizon of black holes through mathematics, building models of the universe's first seconds, theorizing about dark matter, dark energy, the multiverse. We've pointed our instruments at the deepest corners of existence and declared we understand the shape of everything. Pluto was 3 billion miles away. And we had no idea. The universe is 93 billion light-years across, the observable universe alone. Beyond that, we don't know. We can't know. The light from those regions hasn't reached us yet. May never reach us. There are parts of reality so far away that not even information can cross the distance. Cosmic horror isn't fictional. It's the actual, rational response to the scale of what exists. Every NASA discovery, every astrophysics breakthrough, every time we point a new telescope into the deep space between galaxies and find something we didn't expect, we are reminded of the same fundamental truth. We are guessing. Beautifully, brilliantly, scientifically guessing. And the universe keeps answering with something we never imagined. New Horizons has left Pluto behind now. It's still out there, drifting further into the Kuiper Belt, then into interstellar space, carrying a small piece of human curiosity into a darkness from which it will never return. No one alive today will see it again. And somehow, that small spacecraft, smaller than a grand piano, running on less power than 2 household light bulbs, changed everything we thought we knew about dead worlds, cold places, and the boundaries of life's possibility. If Pluto can be alive, at the frozen edge of everything we know, then the universe's capacity for complexity, for surprise, for beauty in the most hostile environments imaginable, is so far beyond our current understanding that our models aren't just incomplete. They are in their infancy. We are in our infancy. Standing at the edge of an ocean we've only just realized is an ocean, holding instruments we've only just learned to build, asking questions we've only just learned to ask. And somewhere out there, in the dark between galaxies, in the silence past the event horizon, in the frozen heart of a world 3 billion miles from home, the universe is still building things we haven't discovered yet. Still hiding answers we haven't thought to look for. Still waiting. The universe does not reveal its secrets easily. It only rewards those who dare to look, and who are humble enough to be wrong. If this made you see the cosmos differently, if it reminded you how small and extraordinary we are, consider subscribing. Every week, we go deeper into the darkness. And there is so much more darkness left to explore.